My background is as a designer, engineering. I was 28 years with Arup and Partners. And he says, those are roughly the topics I'll go in some kind of order, with a view to trying to stimulate discussion as much as, and this is what we've done and this is what the answers are. My background, I've done a lot of zero carbon and similar developments all around the world. But in a sense, you pretty rapidly realize you can't look at this in isolation. Sustainability is the triple bottom line, economics, as well as the social side. We're here to provide a social benefit alongside grappling with the issues of a planet. I also, while I was with Arup, spent 3 years living in Shanghai, which was a bit of an eye-opener. This is the playground for Western architects doing master plans and building designs and getting them built quickly. At a social level, it was a bit of a painful shock what we were giving the Chinese, or what they said they wanted. Yes, you live on the 39th floor or whatever it is. You're surrounded with little landscape areas at the bottom, bleak areas with very little activity happening, very little in the way of active frontage because there's too much frontage. Pudong mid-right is a disaster in master planning terms. Trying to get round it is appalling. You can't walk between one block and another because of the transport system, or rather the cars. So density in itself is not delivering a townscape or an identity of a place. And the Chinese are now realizing, they're scratching their heads, realizing bits of the old French concession area, which is Chinese European moulding of a high density, low rise. How do you bring elements of that back? But, and on the bottom right was an eco-city I worked on, showing the level of occupancy. The footfall to support that community centre, when for slightly different reasons than over here, but most of that is bought as your safe deposit box because you don't trust the banks or investments in China. You put it in bricks and mortar. So you try and get a second home and a third home and a fourth home as your pension. I suppose the thing I found most of a struggle was top right. You enter your foyer, beautifully marbled, you get in a tin sealed box and you go to the 39th floor. Doesn't matter how mixed use that building is, you see nothing of it. And you come out onto your floor with half a dozen other flats and you rarely ever see anyone because you're not lingering. So you got one thinking and talking in the office about proper sky lobbies where you went to there in the lift, you then went up and down 4 or 5 stories from there, possibly walking, a corner shop there, you buy your newspaper, you linger, you bump into people, you actually identify a little bit of a sense of community. So I found it incredibly useful embedding myself in that. And also, top, mid, the office 35 stories up, operable windows. I've been told you can't do it up there. Till you look back, we had a fair number of 30-story towers, residential with natural ventilation. There, largely because the AC was so bloody incompetent, we willingly opened the windows, and that was part of, you realise it was possible. You've got to have the right window furniture on there, the latches and so forth. But actually, there's an awful lot of natural resource out there, cleaner air, things like that up there. But I think, sort of come back to a little more of the environmental side of things, This is a graph which I don't expect you to read every country of the world along the bottom, but there's a trend there of their eco-footprint, in other words, their environmental demands on the planet. And the US and various others are leading the way in the amount of resource they need, and it's the methodology relates it to productive surface area of the planet needed to serve your lifestyle. Now, if we divided it by 7+ billion people, a fair share is about 1.8 hectares. The US is about 5 times that. We're about 3 times that. In other words, if everybody lived to our lifestyle, we need 3 planets. China's about just over 1. But we have sold them the aspiration for our lifestyle. So they're heading in our direction in a very great speed. Now, in one sense, all right, okay, we got there first. But this was, in fact, a very telling diagram. It shows the collective buying power of emerging countries going up. There'll be a few wobbles there in the last few years, compared with the proportion of prosperity growth which is coming from the developed countries. You realize progressively the developing countries are buying up the resource around the world and they can afford it. Is it really of any surprise that Tata Steel see their future back in India? And that's the future expansion business opportunity for them. Now, for us, what does that mean? That means we will be spending more and more on the resources we have to import. Yes, there's energy there, and also carbon, ability to absorb carbon. That is going to be of a very high price in future. And we're already seeing elements of that, I would suggest. The fact that salaries are not going up as fast as cost of materials, for example, is the fact we're having to spend more on it. So if you flip this round and we're looking at our future sustainability, our future prosperity, to actually give our people a proportion of our prosperity as opposed to it disappearing into a Russian bank account for gas or Saudi Arabia for oil or wherever it is for steel, we're going to have to start using an awful lot less material. Now, there is actually a vast potential to do that. But I leave you at that macro level to start looking at then what does this mean for buildings and high rise. And this is where some of the difficult things start coming in. Given the limited time, I'm not going to start saying, oh, well, here's the good things about high rise and here's the bad in sustainability terms over transport. No, I'm taking that as read. There are clear benefits. But there are some issues we're going to have to address. Materials content, 50% higher. Capital cost, now this one's a worrying one. UK spends twice the amount everybody else does per square metre on the high rise. Now, the worry for me is you look at what we've got now and you see where the money is coming from. They're going to be looking at, actually, I should be able to get 2 high rise for the money I'd be giving you yesterday for 1 high rise for their safe deposit box. So the idea of dumbing down value engineering from here on is a little bit of a worrying issue. So how do we maintain minimum standards of what is delivered? Because I've seen some of that dumbing down, and it's not nice. An air source heat pump sitting on your balcony, puffing out cold air in winter and hot air in summer is not what you want on that amenity you provided as a balcony. But that is fundamentally what a heat pump is doing as it puts heat or cooling into your dwelling. The issue that replacement costs are very much higher for many of the major components. The issues of lease periods being out of sync with those main component replacements. So when the cladding needs replacing, 25 years, 30 years or whatever, Are you going to get rid of everybody from the building because they can't live in it while you're refurbishing it? But you've sold the leases. What's the money you have to pay to get yourself out of that position? Will they hold their value if you don't do that investment? What kind of occupants can afford to pay that premium? These are questions which are indirectly related to how we should use these buildings. The idea of mass housing. We know what happens if you've got an occupant base which doesn't match what is needed for the long-term investment and maintaining of what so much effort has been put in initially. We blow them up. Is that where we want to be? That is certainly not very good use of natural resources. Embodied energy, when you look at the numbers, 50-story tower has 60% more embodied energy or carbon than low-rise. Cladding and the M&E are not far off what a low-rise AC would be. But there are higher maintenance costs and so forth versus that revenue I mentioned. The net to gross, when you look at the numbers, does have a significant effect. And quite how one justifies in the longer term a tapering tower with net to gross getting rapidly less long before you actually get to the top suggests we won't be getting any other shards in the immediate future. But it does mean an optimizing of shapes and so forth, which perhaps might not help us if we try and give distinctive features to a lot of these buildings. Now, to try and be positive, you could say, well, if the embodied energy is 60% higher, arguably we ought to design those buildings to last 60% longer, so their impact is no higher than low-rise. And given the amount of effort that goes into it, shouldn't that be a reasonable target? It imposes on the community so much, we ought to be making that kind of extra effort. But do we actually look at what is the life of your building? I've done it on a few. I was the engineer for Portcullis House, 120-year design life. It's a very interesting, different take on how you design when you're thinking about, well, okay, so how do I build in the strategy for replacement of components which don't last quite that long? Operational energy, out on the street, high-rise use twice the energy of low-rise. Once again, if you start looking at the mapping out the numbers and trying to work out, so where's this going, consumption is more related to the lower net to gross. So you end up using more energy on less useful space, given your volume of your building. There's marginally more used due to higher exposure. There's more drafts and higher wind up there, things like that. But actually, that's somewhere less than 5% of total building energy use. There's more energy needed because you have to lift things. But it's not as much as you think, because a lot of the pipe circuits are closed circuits, cooling and heating. It goes up and goes down. So what goes down pulls what goes up. So you actually, the pumps don't need to be that much greater. But on the other hand, it uses double the energy of a naturally ventilated building. And there's so much evidence to illustrate that. And that's more the difference between air conditioning and natural ventilation. So there's people been comparing low-rise natural ventilation with high-rise AC. My feeling is we ought to be looking at natural ventilation at these kind of heights. You've got access to more of that resource. You've got more potential for cross-ventilation and a whole set of things. Unfortunately, the way we've concocted our building regulations positively discourages low-energy solutions in a lot of these buildings. I won't go into detail, but basically if you design an air-conditioned building, you compare it against an air-conditioned benchmark. You compare a naturally ventilated building, you compare it against a naturally ventilated benchmark for compliance. So you can get an EPC B AC, which has got a higher rating, B, than C, which is naturally ventilated, But that air-conditioned building is using twice the amount of energy. Now, that has unintended consequences. Developers are able to tick the box on what is supposed to be the indicator of carbon in the building, but in reality are selling us something which is very different. So where has the innovation components gone? Because we seem to be tick boxing an awful lot on a lot of this. That is a project I've been investigating on the right, which is currently being built in Germany. Net zero carbon, 160 metre high. Basically, you can open all the windows and all the rest of it in it. But there's a whole set of things. We seem to be following a regulation tick box. So why is it the boiler on your typical apartment is now 32 kilowatts plus, or the connection to the district heating, when we used to have a 12 kilowatt boiler in every one of our dwellings 20 years ago? And in fact, you look at the numbers, we could be down at 2 kilowatts, but there's people ticking boxes on regulations. The idea that there's actually a sweet spot of choosing your performance of your cladding such that the energy we naturally generate inside could be used as your source for heating and for domestic hot water. We are renewable heat generators. We are 100 watts of heat, and then everything we do, electrically or otherwise, is also heat source. So the idea of a heat pump to recover that, to provide your domestic hot water, and you insulate sufficiently for that amount of heat. Why do we need district heating and all these things that we struggle to pay for? But it just gives you an idea of some of the issues. But moving more to the buildings and what kind of spaces they deliver. This is something I was looking at a few years ago and scratching my head over, bottom right, some of you will recognize that as a certain building mentioned earlier on, high-rise in the city with a slightly larger top than bottom. How did it get through the system? Well, everybody ticked the box and did the process they're supposed to on the EIA. But you then examine the Lawson criteria, which is what most of this is based on, and you find it's an acceptability for safety, not comfort. It's summarised in the chart in the middle. I won't go into in detail, but what it doesn't consider is things like chill factor. So it just looks at velocities. We nowadays, as we inhabit more of the street, we regard this as somewhere to stay, as opposed to back in the 70s, it's our weather's awful, you don't want a cafe outside, you scamper indoors. The idea of designing a high rise and trying to expect Costa to provide you premium rent at the bottom is, we're missing something. The idea of looking at solar exposure and other comfort criteria ought to be overlaid on this when we're looking at these. The fact that this would then indicate that you look at step backs and so that the wind downdraft doesn't hit where the occupants are is basic physics. The idea of how you then look at street flushing, which we have to do in a lot of our foreign work, but the idea of how you couple this with what proportion of streets, the dimensions of the streets provide you with that. The middle image at the bottom is one I took in Shanghai, showing high-rise set back from low-rise as a way of planning these spaces. The daylight analysis we do is another of those, well, it's an inch thick, but actually planning policy requires you to do a method, but it doesn't define the minimum standards required. And this is beginning to identify we've moved into a new world. Once the aim was that you provided information for the planning assessment or the assessment of that submission to see what is being provided. But we seem to have hollowed out our planners such that none of them actually know what a reasonable level of daylight or sunlight is. And so there is now a manual, which is the EIA, plonked on the desk, and someone ticks the box, yes, they've complied with that. And we're seeing dramatically less daylight in our buildings. The fact that design is not used, so for example, if you've got half the daylight in that courtyard, surely you would expect the window sizes to increase to reflect that as a design, but it isn't being used as a design driver. I could go through a similar thing on overheating, because we have major issues with this, which is predominantly a solar gain. If you group all your windows from your dwelling all onto one facade, it becomes very susceptible to... and then fundamentally, to sort of draw to a close, there's an awful lot of cumulative effects. And it was great to hear GLA are looking at a number of these issues at a strategic planning terms. But a lot of them, like wind and so forth, are not being looked at that master plan level, particularly when master plan ends up evolving. And there's many issues like urban heat island. The fact is, other cities around the world have demonstrated they can get lower temperatures by 2 or 3 degrees using urban heat island mitigation, which will give us a very useful headroom for climate change as it comes along. But, you know, if one looks at, in the bottom, Singapore has got a methodology already identified, which we're now adopting on various neighbourhood plans. So finally, I know some of you may have been to this, looking at the last issue of the magazine. The idea that there is things like this being done, and there was a lot of innovation in London looking at where things ought to go. And there are projects we have been working on, but relatively few see the light of day because of the system. So I conclude, are we within the high-rise approach we're taking, looking at delivering the social communities within these high-rise that we'll appreciate in future? I think there's some questions there. The economics of how in the longer term, because these buildings need more to maintain and so forth, are we considering those, or is it simply can the developer build it, occupy it, and then get it occupied and then flog it? The drivers for that reduction in resource use are still not there, but arguably we should be in a position to start implementing that. The idea of the cumulative effects, the lack of defined standards for a lot of these things, and back to this issue of perhaps we now have a lot of, uninformed is not necessarily the right word, planners who have to shift X number of planning applications in a morning, and therefore the ability to go into them and make those judgments whether the information provided and the daylight inside it is sufficient. And then the issue of innovation versus tick boxing. Thank you very much.